Hi, my name is Leo, and today we're going to be looking at epistasis. To talk about what this means, it is essentially a phenomenon in which the expression of alleles on one loci will be able to mask the expression of alleles at a different loci. As a result of this, the same phenotype can result from different genotypes. There are many types of epistasis, and you can derive that by performing dihybrid crosses and creating ratios of genotypes. The type of epistasis we're going to be looking at today is the single recessive epistasis. And essentially what this means is that if you are homozygous recessive at one loci, this will mask the expression of alleles on subsequent loci. And we're going to be looking at color in koi fish as a fictitious pathway to demonstrate this. So for example, if we start out as a white fish, we will need enzyme A to move on to the orange color variant. But if we are homozygous recessive in our A loci, enzyme A will not be present, and this fish will be stuck as white. If they're not homozygous recessive on the A loci, they can then move on to orange, but they will then be faced with the same problem. They will require enzyme B to move on to the Tancho variant, and if they are homozygous recessive on their B loci, this enzyme will also be absent, and they'll be stuck in the orange variant. An important thing to note is that epistatically, this will move left to right across the pathway, so it actually does not matter what your B loci looks like if your A loci is already homozygous recessive, because the pathway would have already been cut off as a result of the lack of the enzyme, and the fish would already be stuck in the white variant. To show this, we perform some crosses. The first one is a dihybrid cross between two Tancho variants. Our genotypic ratio was 9 to 3 to 3 to 1, which is consistent with that chart on a previous slide. However, our phenotypic ratio was 9 to 3 to 4. To explain this, we have to look at this last square here on the bottom right. We can see that the B loci is homozygous recessive, just like the other orange variants. However, its A loci is also homozygous recessive, and because of the lack of enzyme, epistatically, this pathway would have already been blocked, and that is why the fish shows up as white. The second is between a Tancho and a white fish, and we observed 8 Tanchos, 0 orange, and white fish, and 8 white fish with a phenotypic ratio of 8 to 0 to 8. All of our white fish are homozygous recessive for their A loci, and all of our Tancho variants do not have homozygous recessive in their B loci, which is why there are no orange variants.